Okay, we have another example here. This time we're doing a clinical trial for a new drug to treat insomnia. So we have 18 subjects, and they have a mean wake time of 105 minutes. I believe, somebody correct me if I'm wrong in the comments, but I'm pretty sure wake time is either how long it takes to fall asleep or if you wake up in the night and you're just waking up and you can't fall back asleep. So it's a big problem because you need to be able to sleep. So they've developed a drug. They found that after taking the drug for a while, those 18 people, their um, wake time had fallen to 80.2 minutes with a standard deviation of 21.1 minutes. So that's a pretty big drop off. But the question is that drop off, does that demonstrate that the drug is being effective? Or maybe it's maybe a placebo effect. I mean, we wouldn't be able to test for that. You'd actually want to compare this to a placebo, but we won't do that for now. Or is it just random chance that it happened to fall? Like, yeah, it fell from 105 to 80, but the next week it may go from 105 to 120. So I don't know. Was it just random chance that it fell to 80.2? Let's find out. Now, because our sample size is so low, we have to assume that it comes from a normally distributed population. So you either need more than 30 subjects in your sample or you need to pull them from a normally distributed population. Luckily, most things are normally distributed, so we're good there. Okay, let's build the confidence interval. We have our average X bar, which was 80.2. We have our standard deviation of 21.1. We have our sample size of 18. We know we'll need degrees of freedom of n minus 1 is 17. Again, notice they did not give us the population standard deviation in here, and that's because we don't know what it is. We don't know the population standard deviation, so we'll use our sample one and hope that that's close to the real one. So next we need T alpha over 2. So 17 degrees of freedom, and we're doing a 95% confidence level. So what I'm going to do is I'm going to hop over to my t-table. We have two-tail because we're doing a confidence interval. Two-tail, we want 95%, so the column with my mouse, and we only want 17 degrees of freedom. So it looks like that's going to be this number right here, 2.11 is our critical value. 17 degrees of freedom, 2.11 for 95% two-tail. So, oops, I already forgot what it was. 2.11, I think I said. Yep, 2.11. And with those numbers, you're ready to go. Confidence interval is 80.2 minus 2.11 times the standard deviation divided by the square root of n, which is 18, less than mu, less than 80.2, plus 2.11 times 21.1, that's a little confusing, divided by the square root of 18. So here's your confidence interval. I'm not going to be able to show us an example of doing this with this one, but it's basically the same thing. They tell you what this number is, so you can just plug it in, and then you just get your z critical value from down here, just like you did in the proportion one. So don't worry too much about that. Let's plug her in. 80.2 minus 2.11 times 21.1 divided by the square root of 18 is 69.7, and that is the correct answer. So 69.7 less than mu, less than. I'm going to just do the same thing again and just replace the minus with a plus. 90.69, and that is the correct answer. They rounded it on this one to 1 decimal place, so 90.7. And again, each problem makes you round it differently. I apologize about that, but that's just the way it is. Okay, so we've got our confidence interval. Let me know if you have any questions on how I did that. So now let's answer the question. What does the result suggest about the average or the mean wake time of 105 minutes? Well, notice that 105 is not in our confidence interval. And notice that the entire interval is below 105. So that's really good. That means that it is highly unlikely that we just got this result just by chance. And so that's really good for the drug manufacturer. It's very unlikely that we it suggests that the drug is effective. Now, in real life, you would compare this confidence interval to a placebo. So that's what you would do in real life, but we'll not do that here. But this is good news for them. So what you would say is, because the confidence interval does not include the mean wake time of 105 minutes, so the means before and after the treatment are different. We can say that before, people were awake longer, after, they were awake less. Therefore, the result suggests that the drug treatment has a significant effect. And notice that it says suggests because we would need to do more studies to get more evidence that the drug is effective. So that's how you answer this question. That's how you build confidence intervals. We have a couple more things to talk about with these mean confidence intervals, but we're almost done. And so we will wrap up chapter 7, maybe in the next video, maybe 2 more. See you in the next one.